All right, everybody, we're back. Activity 5 is here. And we're going to do what's called make a cyanohydrin. What is a cyanohydrin, you ask? Well, it's got a cyano group on it. If you didn't know already, cyanide, the ion, when it's attached to a carbon, becomes cyano, the group, much as bromine, the anion, Br minus, bromide, becomes bromo when it's attached to a carbon. The cyanos behave a little like halogens, so they name them like halogens. Cyano. Hydrin, back in chapter 6, when we learned how to make halohydrins, we learned hydrin was alcohol. Please remember that. It seems to be popping up more than once. Its mechanism is, it's about the same as the NaBH4 one in terms of level of difficulty. We have to activate the carbonyl towards attack by a nucleophile. There's no other acid except for HCN present. It's a mild acid, so this step is incredibly, it's not, I don't know how to say it. I do know how to say it. It's not equilibrium favorable, but this does not bother chemists. What do I mean by not equilibrium favorable? Well, hydrogen cyanide, you don't have to memorize its pKa, but if you made a guess, you'd say 10. And every time I say, when you make a guess, it's just me. I'm just implying that pKa is 10 because there's so many of them that are close to 10. So does acid-base chemistry going from a 10 to a -3 happen favorably? No. It goes very little towards products and stays 99.9% reactants. More than that, actually. What's the difference between 10 and -3? 13. 10 minus -3, 13. So it takes 10 to the 13 of these before you see one of these. This doesn't bother chemists. I can still make this reaction give 100% yield. You know how I know that? Because this next step is not equilibrium. Not equilibrium means what happens is after you've protonated and got your 1 out of 10 to the 13 ratio, you're removing this molecule from equilibrium by reacting it. It's gone. What does Le Chatelier say about removing a molecule from an equilibrium? Le Chatelier says you must replace it. So after you remove it, the unfavorable equilibrium is forced to make more. Reaction, forced to make more because you got rid of it again, and reaction. Everything gets dragged this way. And it's a fascinating thing in biology, this reaction. There's a certain organism that does this. It eats foods, and it has metabolism, which is pretty incredible because HCN is one of the most toxic substances known. And this animal stores the cyanohydrin in a gland in its body, stores that, and when it's alarmed by another animal, it has an enzyme that catalyzes the reverse reaction, which creates hydrogen cyanide, which either paralyzes or kills its prey. So if you have a squeamish stomach, you might not want to watch the next part of the video. I'm going to show you what this organism looks like. If you don't like bugs, you might not want to watch. Here it is. I think it's still in the memory here. Oh, it's called a millipede. And it sequesters the hydrogen cyanide, stores this. When it's alarmed, it kicks it out. I think it does it out its butt here, and it makes hydrogen cyanide and benzaldehyde. So the other animal gets poisoned, and it smells like almonds, because that's what this is. That's the almond odor right there. I don't know. Interesting side story. I'm going to get rid of the bug. There you go. That's a millipede. All right, that's the end of this one. I will set it up so we can do our next one. Here we go.